Fat Finger Squad in the building. We got my man S Smooth checked in. What is going on? Let me check my labeling here, because today we are doing hardware again. Let's see, the switch need to be plugged up to router 3, right? Switch need to be plugged up to router 3. This is the lab we are working with today. We just go ahead. I think you should be able to run this in Packet Tracer. Most likely you should be able to do it in GNS3 or even G, whatever floats your boat. I, of course, am going to be using hardware, so if you can, go ahead and drag and drop 2 routers. Router 1, a router 3 for some reason, and a switch 1. So 2 routers and 1 switch. I just had to double check the cabling because I didn't see this one light up over here on this side. I didn't see this interface right here light up. And I think it's just because that interface right here is down. So y'all know how I do. I just get the labeling and cabling done already. Obviously we got the label here with this topology, and I get my cabling done before the stream, so I'm gonna just give it some time to you're killing me, Indrid. See, I almost called you Even G, man. Names start with it too. He talking about he gonna log off because I'm using hardware. Man, listen, man. I'm gonna go back to Even G, but y'all, like I said, I had this rack of equipment here that was a museum exhibit for a while, and now that I'm actually labbing every day, because that's what we try to do to learn this stuff, right? Lab every day, get our hands dirty, and I'm actually labbing with my equipment. So that's why I was like, well, am I gonna get a you know, some emulators and stuff though. Look at that. We got one less viewer. That must be him too. He must have logged off. Look at this dude, man. Come on, man. Come on back, man. We got Dave W in the building. What's going on, Dave? I'm just gonna give it a couple minutes for some late stragglers to come in, let them know how we do on this channel. Let's see what else we got on the agenda today. So yeah, basically, if you don't know, we typically lab from this book right here, 101 Labs Cisco CCNA version 4. You can copy this from 101labs.net. It's authored by Paul Browning and Farai Tafa. I sound like a broken record, but experts agree that we retain only 10% of what we read and 90% of what we do. And that is why I love this book right here, because it gives us something to follow along here and try to grasp the concepts that we learned from those dry ass books, man. So anyways, today we're going to be doing lab number, what is this? Lab number 63. Oh, and it's episode, I guess it's episode 50 today? Is that where we at? Yeah, 50 episodes deep, man. You know, when I started this channel, I started this when I was studying for the CCNP switch exam. I just passed the switch exam, but I knew the route was going to be a pretty tougher exam, because routing was not my strong subject at the time, and I still feel like I'm kind of weak in it. So I said, in order to document my my progress and to I guess, how do I say, not verify my skill, but just to kind of like, you know, they say that you actually learn a subject, or you actually know a subject, if you're able to teach it. So I said, okay, well, why don't I start a YouTube channel and teach what I actually know? Plus, I like sharing knowledge and stuff. So that's what got me to start this channel. And, you know, it was pretty much a different format when I started this channel. You can go back and watch some videos on this channel. I had like basically tutorials for each topic. I just went along the bullet point and just basically did little short tutorials. And then I would do some hands-on and demonstrate the topic, right? But then as of this year, I started live streaming and stuff. And I'm like, shit, this is even more fun than just doing those tutorials, because those tutorials, I had to grab some PowerPoints, learn the subject, and then try to teach it, and it was just a lot. So I'd rather just like freestyle it, you know? So live streaming and just, you know, just talk shit to y'all and actually try to, you know, learn at the same time. So that's what got me to start live streaming. And I guess we're now 50 episodes deep, so maybe I'll do a giveaway on 100 episodes or something like that. I'm really waiting on a certain amount of subscribers before I start doing some more giveaways. I did a giveaway when I had when I reached that first milestone, about 1,000 subscribers and stuff. So, you know, I'm just trying to grow my channel and stuff. And y'all like this video, go ahead and hit me with that like button. That really helps me out with this channel. I've been really appreciating the support. I've been, you know, having people DMing me and telling me what topics they want to see. After this book, once we cover this, I said we're going to start doing, that's what I was actually studying for, was the CCNP exam, but I'm just using the CCNA book to kind of go back and cover the gaps in my knowledge and, you know, just redo the fundamentals. You know, you always want to go back to the fundamentals. It's always great to lay down your groundwork and stuff. So anyways, lab number 63 is configuring static network address translation. The objective for this lab is for us to learn and configure NAT, right? So NAT configuration is a fundamental skill. Static NAT provides a one-to-one translation between a private IP address, RFC 1918, and a public IP address. And y'all know the difference between the two, right? Public IP addresses are IP addresses that we use out on the internet, right? Whereas private is, you guessed it, we used it on the local area network. There's a range. There's ranges like, what was it? Jesus, I can't even think on top of my head right now. The 10 address space, the 10, like 10.0.0.0 is a private IP address space. The 128, correct me if I'm wrong. Yeah, that's like 127 to 128 subnet is a private IP address space. And also, no, I'm sorry, 172.16 through 31, and also the 192.168 IP address range. Those are all private IP address range. They're not routable on the internet, right? So if we want to, what we would do is take our private IP addresses and translate them to a public IP address. That's the point of NAT. And the reason why they did that was because we was running out of IP addresses and stuff like that with IPv4, and natting was a way to kind of like recycle it in a way. So that's just in a nutshell of what NAT is. Y'all want a really deeper explanation, go on my channel. I did a full tutorial when I used to do tutorials and stuff like that. Now I just give you like a little brief definition and we just lab it up. And hopefully you guys got your emulators and simulators or whatever. I know Endrick got his EVE-NG powered on because he loves EVE-NG, and y'all know I love my hardware. So what else they said here? Static NAT is typically used to provide access to private inside hosts from outside hosts or networks. When static NAT is configured, outside hosts or networks connect to devices on the inside using a public or external IP address. This hides the private IP addresses of hosts on the inside. And like I said, we can't use private IP addresses on the internet. They're not routable on the internet. So what we do is use public IP addresses. And in the internal, on the local area network, so like this case right here, this is part of that range that we were talking about. 10 network, right? This is the local area network. I know it says 192.168 here, 192.168 here, but this is just for a lab. This is lab reason. That's actually a private IP address space. I'm just now realizing that too. But this is a private IP address space. Typically, these would be a public IP address. So before some jackass come into the comments over there. But anyways, how long have I been in IT? Man, that's a good question, Dave. Dave, I've been in IT since 2000 and officially 12. So I got my first IT job working at the police department as a PC technician. So I was actually working as like a 911 dispatcher. And then I graduated college. I went to UCF and majored in management information systems. And once I got my degree, I started looking for work. And while I was working there, they just happened to have an open IT department. I applied and I got a job. So I've been working as a PC technician. And then I moved on to working in the help desk. And then I moved on to working desktop support for the school system. Then I started working in the network operations center. Prior to that, I was working also the service desk for local area network. Then I started working for the network operations center for a managed services provider. And then I moved on to the healthcare system working as a network analyst. So I was kind of like a network engineer, but I was more of an analyst because we was working off of config templates and racking and stacking equipment. And now I'm a network engineer. So I guess from 2000, you didn't just answer your damn question. Gave you the whole resume over here. Yes, S-Move got the IP address range right there. 172.16 through 31/16. Yes, that is, what are you not sure about that IP address range? That is one of the private IP address spaces though, S-Move. So from 2012 to now. So 10 years I've been in IT. But I guess about a year as officially as a network engineer. So I pretty much worked my way up the ranks, man. Still waiting for some people to straggle in. And I usually like to start 10 minutes into the lab or into the stream. So let's go ahead and get started here, right? So first task, we only got, how many tasks we got today? I believe we got a bunch today. I looked over it today. 7 tasks. Right? Task 1 is to configure the host names on router 1, router 3, and switch 1. For some reason, they put router 1, 3. I guess they skipped router 2 for some reason. I don't know why they do that. Throughout the book, they did router 1 through router 3. I don't know why they do that. And then switch 1, right? So, and I've already, like I said, this is my hardware. I've already got them labeled up and cabled up. So that's router 1. That guy's router 3. And that guy's switch 1. If you guys don't know how to change the host name, let me know. And we got some other people in the chat room that are really smart. Remember, even if it's a simple task and you think it's simple, ask anyway, man, because we got a lot of smart people in the chat room. And we will, you wasn't sure about the math. Yes, it is /16 for that range, if I'm not mistaken. Yes, 172.16 through 31. So the first 2 octets. The last 2 we don't care about. We do care about it, but that's the private IP address range. It starts exactly with what you said. That's the Class B private IP address range. There's also Class A, which is the 10 network. So anything in the 10 network. And then the Class C is from 192.168. whatever. That's the Class C private IP address range. Damn, I never knew. That's what's up. Glad to tune in on your journey. I was going to watch your vids from the beginning. That's what's up, Dave, man. Yeah, man. I've been in IT for that long, man. It might not seem like it because I don't know. I just be acting immature in my videos and stuff, but or unprofessional. But you know, that's how I do. I keep it funky on this channel, man. That's how I do, man. I try to be different, but at the same time, you know, try to make it so that way everybody's learning and stuff. Try to keep it fun. So we already did the host names. Y'all know how to do the host names, right? You just go to global config mode, and I'll do it for anybody that doesn't really know or if too embarrassed to ask, right? If you want to change this, let's say he's just named router, right? You want to change him to the host name, you just configure terminal and then host name, and then you change it to whatever you want. So R whatever, all right? And it'll change it, but I'm not going to do that now. This is just for anybody that's new in here. So, and y'all know I go back to the fundamentals. I don't care how simple the task is. I remember working at a job. Somebody was like, I asked a simple question. It was simple at that level that I should have been at, but, you know, the way he answered it, it was almost like, you know, I'm not going to ask the motherfucker a question again, man, because he like to embarrass you. So I try not to do that with people, you know, even if it's a simple task or a simple, you know, like we said, there's a lot of smart people in the room. They'll help you answer as well. So we ain't got no trolls, not yet. I ain't that popular. So task 2, configure router 1, which is this guy right here. Switch or serial 00 minus serial 000. So that interface right there, which is a DCE to provide clock rate of 256 kilobytes per second to router 3. So basically, we got to have, oops, why? This right here, DCE, which stands for Data Communications, what is that again? Okay, data clocking. Let's look it up before I start to making shit up to y'all. DCE serial is data communications equipment. So this side, this is how I remember it. Anything with the C, this lets you know that does the clocking, right? So this does the clocking right here, right? And it's going to provide clocking to the other side. That's what they wanted us to do. They want us to provide clocking at a rate of 256 kilobits per second, right? So we're going to go to router 1, that interface right there, and do that, right? Y'all seen this a million times on this channel, but we're going to do it anyway, right? Just in case nobody knows how to do it. And remember, when we get to the CCNP level, I'm going to be skipping all this simple stuff. So, almost did that. Serial 000, right? And then we do the clocking with the command clock rate, and then 256 kilobits. I need to fix that because now I can't see my cursor. Kilobits per second, like that, right? We could verify that with show controllers, serial 000, oops, 00, and we'll see that we are indeed the DCE side, right? Because I put the cable over there. One side is DCE, the other side is the DTE, which stands for Data Terminating Equipment. That I remember for some reason. And what else we got here? We verified our clock rate is 256 kilobits per second. So we are clocking at that range. If you don't know what that is, basically, the reason why you don't really, I realize this too. We do this on a home lab because we're actually playing the role of the ISP as well as the customer side. So typically the ISP is providing the clocking to you. So this would be kind of like, you know, Bright House or Spectrum or CenturyLink or whatever, right? So this is our ISP, and they're providing the clocking to the CPE side or the customer side, right? You typically ain't got to worry about the clocking side unless you're doing like service provider stuff. So that's why you ain't got to worry about that. But that's what the clocking is, and they made us do that over and over in these labs here. So let's go ahead. We did that, right? Task. What else they wanted us to do? On the same task, configure the IP address on the serial interfaces 1 and router 3. So basically, they want us to configure that serial address and this serial address, right, on the serial interfaces. So we did the clocking on this interface. Configure a terminal. What do you say? What do you say? What do you say? Damn, I never knew. Data communications equipment, I believe. Yep, you're right, Tori. That is correct. Data communications equipment. So interface, we're going to go back to that interface. Serial 000. I want to fix that, man. I'm going to fix that. I can't see my cursor anymore. Y'all give me a second here. Where my damn cursor at? Cursor. Block. He's block. He's color. He's blinking. Short block. Come on, man. What happened to him? He's black? Oh, that's why. I wanted a, let's do a white cursor. Maybe that's why. Boom. There we go. I was looking for a white cursor. All right, so the interface, IP address. So IP address, y'all know how to do that, right? 192.168.254.1. Subnet mask of 29/29, which is 255.255.255. Unique octet is 240.224, right? Y'all get that subnetting, remember? Practice Subnetting is the app that I always use to get that correct. Let's go ahead and do a no shut, because I believe router interfaces are shut down by default. We'll do a show IP interface brief, see what we got so far. And notice he is still down. Why is that? Most likely because this guy is also down. Down. We go to router 3. Let's go to router 3 and configure this interface right here. Right? So 192, so we said serial 000, configure terminal, interface serial 000. Once we bring that up, it should bring up the interface. So 192.168.254.2 / what they said, 224, right? 255.5.224. No shut that bad boy. And we should see, let's see, router 1, 000. Yep, now it's up, right? See, now we see it's up. We do, we confirm our work, right? Always confirm your work. I don't care how far. You could be 2% into the lab, man. Know your show commands and run them. 192.168.254.1. He's up. Let's verify the subnet mask, right? Show IP interface brief, or show IP interface serial 000. Right? Let's do that. And then he is, see, that is wrong. I put /27. You see, that's why we want to double check our work. I'm sitting here talking shit like, see, I know how to subnet. I put the wrong subnet mask, right? So let's go ahead and fix that. Both of them. Let's go to interface serial 000. See, this is why I'm glad I checked that, right? See, it's /27. It's supposed to be /29. So the subnet mask is not, it's actually 248 now that I think about it, right? So let's fix that. He said IP address. Come on, man. IP address is 192.168.254.1, 255.255.248, right? And now show do show show IP interface serial 000 use now it's correct. So it's .248 is what I needed to do. So I need to go back to this guy right here and fix that, right? So go to router 3 and fix that. Trying to show off with my mental subnetting, knowing damn well I ain't that strong yet, right? So IP address, let's fix that. It's not .224. It is actually what he said. He said 2. Come on, you just said it. 248, man. What's wrong with you, man? And let's verify our work. Show. Oh, I need to fix the cursor on this side too. Show /29 should be 248 on the serial. Yes, appreciate that, man. I'm glad you said that. And Tori said to check out the Boston free subnet calculator. Yeah, y'all check that out too. There's a couple subnet. There's tons of subnet calculators out there. SolarWinds got a free one that you can download, and it's pretty robust. There's tons of free subnet calculators that you can get on your phone. The one that I use is not really a calculator. The one is just basically it's a way to practice subnetting. So you could practice, it's just like you could practice addition on a calculator, right? But if you don't know the math behind it, if you don't understand it, it's just giving you the numbers and you don't know, right? So practice subnetting generates random IP addresses, and you got to figure out the first host, the last host, the broadcast address, etc., etc., etc. So, but like he said, there's also Boston also has a free subnet calculator. So y'all check that out. Let's verify the subnet here. Show interface serial 000. And let's see if I did it correctly that time. I did, right? 192.168.254.2. So I did it correct that time, right? This is why, y'all see? And I be thinking to myself, like, man, I got this, man. And I'm always preaching y'all to always run a show command. I don't care how simple the task is. Even if you like only 2% or 3% of the lab done or whatever you're done, just consistently run show commands to check their work, right? Now, that was task 2, right? We only got 7 tasks today. That was task 2. Task 3 was to configure VLAN 50. So they basically want us to go on the switch here, right? Because that's where we configure our VLAN. So they want to go on here and create a VLAN number 50 on switch 1 and name it nat_VLAN, all caps, right? nat_VLAN, all caps, on switch 1. So let's go ahead and do that, right? So let's go to switch 1. What else we had on the agenda today? On the news, Robert De Niro, man. This dude is going through another divorce, man. Apparently he married the same lady, or he divorced the same lady. I think I got this on here already. VLAN 50. I'm just going to do that just in case, right? So now show VLAN brief real quick, just to see what we got so far on here, because I think I had some stuff in here, right? I got a Europe and an Asia VLAN 2 and 3. So we're going to create a VLAN. Y'all know how to do that, right? Go to global config mode, if I know how to type, and you just say VLAN 50, right? That creates it, and then you want to name it. They said they want us to name it nat_VLAN, just like that, right? We can show our work. Always verify your work. I don't care how simple it is, right? Show VLAN brief is how we check. So yeah, man, the man got divorced, and then he went and got remarried to her again. They've been married for like 20 something years, and she finna divorce him again, man. And he got to take any role in movies just to support her lifestyle, because he just got to keep up with it. He got to pay her, I don't know, like $4.2 something million a year, some crazy number, man. This shit crazy, man. But anyways, VLAN 50, Nat VLAN, we did that correct. Did they tell us what they want us to do? They said they want us to assign FA02. So this interface right here, they want us to assign it to that VLAN, VLAN 50 right there, right? On switch 1 to this VLAN. So they want us to put that port in that VLAN. So we go back, global config mode, configure RT. Interface FA, I don't think mine is FA02 on my switch. My interfaces and your interfaces might be different. So y'all make sure y'all check that, right? So you might not have serial 00, just like this has serial 00, mine was actually serial 000, right? Because I've got like 4 WAN ports on these switches. No, I mean on these routers. I got 2 WAN ports on these routers. So, and my interface is actually going to be FA102. So y'all double check that before you start configuring stuff, man. Go back to global config mode. How much of this do you do at work? Good question, man. Do it every day. Creating VLANs, not necessarily creating them, but having to put ports in certain VLANs. Today, I pretty much had to use Cisco iOS, but not in this sense where I'm creating a whole interface and doing natting and stuff like that. That's not something that's done every day, you know. Not in my role. A lot of times it's almost like set it and forget it, right? You configure the natting and it's done, right? So today, what I had to do, I can tell you what I did today at work. So we had a couple like projectors and stuff that get powered on with PoE. We had some phones that get powered on with PoE, right? Power over Ethernet. If you don't know what that is, I got a video on my channel. And they were not powering on. So I had to go out there and figure out what was going on. Obviously they weren't powered on. So I go to the switch where the switch is in the closet, plugged in, and it was throwing these errors, and it was saying PoE overdrawn. So it was basically like, I guess, it went over a threshold. So it might have been giving too much power, or maybe the phone was drawing too much power from the switch. But I'm like, it had enough space to power on more devices, and there was a couple PoE devices that were powered on. So long story short, I checked the log, found out what that error was, and basically it was a bug in iOS. So I had to pretty much roll back the iOS that was on it. It was upgraded last week because of power outage. And then what happened? So basically I set it to reload tonight. So hopefully that fixes the problem. I'm gonna check it tomorrow. Had some other things, but I'm not gonna go off track because we got some people in here that want to learn. So we go back to, what did they say they want us to do? They want us to put that interface in that VLAN, right? So interface FA102 in my case, switch port access VLAN 50, right? That puts him in that VLAN. We can verify our work with show VLAN brief. I need to fix this one as well. My cursor, I wanted him to be in white. Okay. Okay. I got a cursor. And we have FA0102 rather in NAT VLAN. VLAN 50. So that's correct. Also, configure switch 1 to allow Telnet access using the password, all caps, Cisco. Please don't use that password on your at work, man. Security reasons here. Or at least so much for security. So they want us to allow Telnet on this router, right? On this switch, rather. So basically, what they're going to have us do, I believe, as if I didn't do this. They want this switch to be to allow Telnet right here, right? So that way we can remote into it. Basically, they're going to have this router Telnet into that guy right there, right? But we need to allow it. We need to set it up and to allow Telnet to happen, right? So we go back to global config mode. We go to line, not the console port. We want to do line VTY 0 through 15 in this case. And then we want to do transport input Telnet. That's going to allow Telnet. And they also wanted us to set the password to Cisco. So password, simple enough, right? All caps. As I go back to lowercase, Cisco. And we verify our work, right? I don't care how simple it is. Verify your work. It's just like clicking the save button when you're in an Excel spreadsheet or you know, a Word document, because you ain't got an auto save or whatever, right? So I like to do show run and then begin, actually section line, all lowercase, and then that'll show our work there, right? So we set, these are our Telnet lines right there. So we're allowing Telnet, as you see in the red, on all these VTY lines. We have the password Cisco, but notice it says here no login. So even though we set the password to Cisco, it's not going to prompt for the password. So we got to change that. This is exactly why I'm glad I checked my work. Man, I don't care how many times or how far you're into it, man. Make sure you check your work. Because see, I forgot about this part right here. You got not only set the password, but you got to make it so that way it checks for the password or prompts for it. So we go to global config mode, conf, if I can type right. Interface, I'm sorry, not interface. We said line VTY 0 through 15, and we got to do just login. That's gonna prompt for login. See, I'll even show y'all, right? So we do log like that. It don't even say. It don't even give a definition. It don't give a definition. But either way, that prompts for checking. Now check our work again. Show run, pipe begin line. What we got here? And now that login right there. Remember it said no login right here. Now it's going to actually prompt for the password once with that password right there. So what he said, but serial stuff, how much do you actually work with that? The serial stuff, not at all, man. I ain't gonna front. I don't do any, and when you say serial stuff, you're talking about like configuring the IP addresses and stuff like that. I didn't have to do that very often. So far, I had to do this like twice, actually configuring the IP address for specific serial interfaces. Like serial interfaces are pretty much going by the wayside. Nowadays you got fast Ethernet, you've got gigabit Ethernet, you've got 10 gig E, you've got 40 gig E. They got like 100 gig E now. So serial interfaces are kind of going by the wayside, man. What else? Oh, the clocking neither. Remember, the clocking comes from the ISP side. What's going on, Osiris? Thank you for checking in. Transport output Telnet is for SSH, right? That is incorrectly. Transport input SSH is for SSH. Good question though. So you could do both actually. Just to clarify for you, go back to global config mode, right? Global config, and we say interface. I'm sorry, I keep doing that. I'm so used to going to interfaces. Line VTY 0 to 15, right? If you do transport input, right? You question mark, you'll see right there. You can do all protocols. You can allow nothing to remote into this device. You can do SSH, or you can do Telnet, or you can also do SSH and then or prefer SSH and then do Telnet, and then after that just drop it if they're using some other protocol. But in this case, you would do transport SSH or input SSH is if you want to allow SSH only. I was just curious because we don't see serial at all. Exactly, same here, Tori. Oh, transport SSH. Yeah, so yes, exactly. I'm glad you guys clarified that, man. Thank you for asking these questions, man. If something's not clear, ask away. So that was task 3, right? Yes. Task 4. We only got 7 tasks. We're almost done here. Configure interface VLAN 50, which is that guy right there. On switch 1, which is this guy right here, right? And assign that the IP address is illustrated in the topology. So basically, they want to give us that IP address. So let's go ahead and do that, right? Are we on the switch? We are. So we're going to go back to global config mode. We're going to interface VLAN 50, right? That's going to create a virtual interface, right? It's not the same thing as a physical interface. Remember, we got these ports right here. These are our physical interfaces, right? Then we have this guy who's going to be our virtual interface. So it doesn't pop up out of nowhere, right? But notice he is down right now, right? I'll even show y'all real quick, right? Do show IP interface. Oops, IP interface. Interface brief. I need to step my typing skills again, man. Right? So there's interface VLAN 50 that we created right there. He is up, down. So he's not completely up yet, right? We gotta I believe we gotta no shut it, and we gotta give it an IP address, and also have a device at least plugged up to that VLAN. Yes, that's why. So let's go ahead and do that. So we created the VLAN 50. They want us to give it an IP address. Right now it's unassigned, right? So the IP address they said was 10.224/27, right? Hopefully I get the IP address correct. the mask subnet mask correct. IP address 10.2.2.4. And I know somebody in there got a subnet calculator, so go ahead and fact check me there, right? 255.255./27 should be 24. That should be 224 because that's what I typed the first time, right? 224, right? I believe you no shut it. He's still not gonna come up, right? So IP interface brief. I need to get rid of that too. The logging synchronous there. Exclude unassigned. And he's still up down, right? Until we put a device in VLAN 50, that's when he'll come up. So notice he's still up down. We need it up, right? So that was task 4, right? I believe that was task 4. Yes. We're not done with task 4 though. They said the default gateway on switch 1 should be 10.2.2.2. So basically, what we're gonna do here is remember he's a layer 2 switch. He is not a router. This guy right here, he's actually a layer 3, but right now he's not configured for routing. So since he's not going to be configured for routing, we need to give him a way to get out of the internet or get out of his local area network. The way we do that is by creating a default gateway, right? Same thing as a PC. He needs a default gateway. They said they wanted the default gateway to be 10.2.2.2, right? So we go to global config mode. We say IP default gateway. So basically, if he says, okay, he gets some traffic, he don't know where the hell to send it to, just send it out to the default gateway. That's what the default gateway is, right? 10.2.2.2. And who's that going to be? This guy right here. So anytime he gets some traffic on this local area network, and he don't know what the hell to do with it, he needs to send it out his default gateway, which is 10.2.2.2, right? And that's what we define with this this command right here to do, right? So y'all run me that like button if y'all like what y'all see so far, man. And make sure y'all subscribe, man. We also have a Discord server if you got like further questions after class and stuff like that. I typically stay up late to do a little bit more studying, and because I ain't got shit to do, right? And you will see serial and legacy environments. That's correct, exactly. Our network team has been outsourced to India, unfortunately. Oh man, that's unfortunate, man. But there's a lot of remote work that's out there. Make sure you keep looking. Keep your resume updated and let them know, man. Be like, hey, man, I watch NetworkBruh, man. You should hire me. Task number 4 said the next configure interface FA00, which is this guy right here on router 3, and assign the IP addresses in illustrated topology. So that guy right there, they basically want, this is the default gateway. So not only did we have him point to the default gateway, we now have to configure this default gateway, right? We got to configure it on this router right here. So let's go ahead and do that. We go to router 3. Andre, where you at? Man, you quiet, man. Did you really leave this stream because I'm using EVE-NG and I'm using hardware? In case you guys are just tuning in, man, this guy, he taught me how to use EVE-NG, how to set it up and everything like that. I'm like, okay, great. But I'm using my old ass routers and switches to teach you guys this stuff, right? But because it was just sitting in my, sitting there, man. I needed to use this stuff, man. Interface FA00, I'm hoping that is. Yes, it is. The IP address is 10.2.2.2. Subnet mask of /27, which we said is 224. Oh, I need to fix his, looks like I need to fix his block too. Jesus, man. I need to do that for all these guys. Let me make that the default. Let's make that the default. Real quick, y'all. We said block, color, white, okay. Change all sessions and make sure they are all that way. Right? Did he change? I don't think so. I probably would have to reload him. Let's go ahead and do that. Please come back though. Reconnect. And there you go. He got a white block. So everybody else is going to have a white block. That's what I needed, man. Needed some white. Interface FA00. Did we do that interface? Let's check our work because I can't remember. I'm sitting there trying to crack jokes and shit. Exclude unassigned. What am I doing here? Show IP interface brief. And we said, yeah, we configured him. But notice he is admin down. So this guy right here, that interface right there is down. We need to bring it up, right? And then that should bring it up, right? So let's go back to global config mode. Interface FA00. I hope I did the cabling right. No shut that bad boy, right? And typically that should bring up that interface too. Both interfaces. The switch, notice the switch is coming up. We got FA102 is up now, right? And where is VLAN 50? We put in FA102. This guy's 102 right there, right? Y'all remember that. What happened to my interface VLAN 50? He need to be up. We need to make sure he's up. Show IP. Let's do this. Yeah, show IP interface brief. He's still up down. We put in 102. There you go. Now he's up. You know what it was? Spanning tree. Spanning tree is the reason why it didn't come up yet. So I think. No, I don't think that's why. Oh no. So yeah, we configured that address, and we also on router 3, which is this right here, FA00. He is up as well. Let's check our work again. Show IP interface brief, and he is up. That's up. That's admin down. We ain't worried about that one. This one is up. So this is good to go. That's good to go. The serial interface is good to go. This guy's good to go. Right, so what else they want us to do? Test connectivity from router 1 to router 3. So they basically want to have router 1 ping that guy right there. Right, so they basically want us basic connectivity, right? So we should be pinging 192.168.254.2. He says CDW is always looking for associate engineers. We train WF. Oh, that's what's up, man. Yeah, they are always looking for engineers, man. Yeah, holla at me, man. No, I'm just kidding. So layer 3 switch doesn't need IP routing command if only use the default gateway command. Work from home. Yes, that is correct, Pete. So I'm glad you asked that question. So right now, actually, let me ping it real quick. We're just going to ping this right here, and then I'm going to answer your question, right? So we're going to ping this guy right here from router 1, right? And pray to the network gods, and we didn't even have to get on our knees right there. We got 5 replies there. So you wanted to know this guy, is he doesn't need IP routing command. That's correct. So right now he is listed, he is a layer 2 switch. He has layer 3 capabilities, right? Because this is a 3750 switch, right? But if you don't turn on IP routing, right? If you want to get out of your network, you need a default gateway. And that's how we do it with that command that I just showed you. IP default gateway. This right here. Right now he is not. So if I do show IP route, show IP routes. Right now, you see, right, you know what the IP routing table typically looks like, right? You'll see the legend, it'll say EIGRP, OSPF, and all that other stuff, and then it'll show you some routes, right? But right now, it says right here it's empty. It ain't got all that because this is routing function is not turned on this router, even though it has the capability to do so. So yes, that is correct, Pete. Because I did not turn on IP routing, I have to use that IP default gateway command. So very good question. And y'all holla at Tori because they looking for people apparently. So that's we was able to test connectivity there. What else they want us to do? And pinging from router 3 to switch 1. So now they want us to ping this guy to that guy and test connectivity. So basically we're gonna have him ping that IP address right there because that's his management IP address. Well, not necessarily his management. So we're gonna go to router 3 and test connectivity. Pray to the network gods. And it's 2.4. Waiting. Looks like we got a reply. All right, so we had two drop packets there, and 3 got it. So we got 60%. So we run it again. we should get 100%. So we're good to go. So this guy's good to go, and this guy's good to go. So we got testing and connectivity there. We're good so far. That is okay. So that's still task 5. However, since router 1, this guy right here, does not know about, so he was able to ping there. This says router 1 does not know about the 10.220 subnet, right? So this network right here, he does not know about this network right here, right? He does not know about it. He know about this network right here, obviously because it's directly connected to him, but he doesn't know about this network. So we need to have like either some kind of dynamic routing or some kind of static routing to know about that network, right? So, and it says here, does not know about that subnet. Switch 1 would not be able to ping router 1. Verify this. So basically switch 1, and since he doesn't know about that, then theoretically he does not know about this network right here. Or he can't ping that guy right there because of we need to have bi-directional connectivity. That's what that is. That's what that's called, right? Because a ping is basically that. It's like a sonar, right? It sends to one end and it's supposed to come right back. That's how you know you got good connectivity, right? So switch 1. Let's go to switch 1 and have him ping this guy right here, right? They said he is 192.168.254.1 ping, and it should fail. That's somehow my switches and routers and cables got some kind of voodoo and is able to do it without me configuring it. But obviously we got some failed replies there, and it's not working just like they designed it to not work, right? So task 6, we only got 7 and we're almost done here, y'all. Task 6, configure router 3, which is this guy right here, as the NAT inside NAT interface, or router 3's FA00. Here, let me explain this again. Router 3's FA00, which is this guy right here, as the inside NAT interface. So they want this to be the inside, right? I'm not going to type in the whole damn word inside, but you know what I meant. They want this to be the inside. So in other words, this is going to be our local area network. So I don't know, your house, your school, whatever, right? So this is the local area network. This is going to be the inside of the network, right? That way. This way. That's the inside, right? So guess what this is going to be, right? You guessed it, the outside. So this is kind of like the internet, right? We treat the internet like the WWW, right? Wild Wild West, because it's the anything goes, right? So it's considered the outside of the network. They want us to make this the inside interface and that the outside interface. I didn't read that part yet, but that's basically going to have us do. Spoiler alert. That's going to be the outside interface, right? So that's what we're simulating here. That's going to be local area network. That's going to be the wide area network. So we'll go to router 3 and go ahead and do that, right? So we go to router 3, FA00. So this interface right here, right? That guy right there. Go to global config mode, interface FA00. We said IP NAT inside. This is how you do it, right? I'll go in a question mark for y'all. Every NAT statement starts with that. IP NAT, right? And this is how we transfer, or not transfer, but we create network address translation. We map inside addresses to an outside IP address. This is called static NATing because we're actually taking one IP address that's on the inside and mapping it to one outside IP address. Now this is not very scalable because we're gonna have this is called one-to-one mapping, because we're gonna have one-to-one mapping, right? And it's just like, it kind of defeats the purpose of NATing, because we did NATing to kind of like save IP addresses. But if we're doing one-to-one and we do it one-to-one, and we got 500 hosts, then we have to have 500 inside addresses to 500 outside IP addresses. And and public IP addresses, they actually cost you money. So this would defeat the purpose. But this is just a way to kind of like explain, to show you what static NATing is, and you just need to know it for the CCNA exam. So if you're taking it. So let's go and do that, right? We said inside, IP NAT inside. So this is going to be the inside interface. And then we want to do this guy as the outside interface, right? And notice, this is the other thing too, which this is why I like going back to the fundamentals here too. Thanks to the NetworkBruh videos, man. I appreciate that, man. Don't have CCNA, but in 2 months. You will, man. I promise you will. So notice it created this interface, NVI0, which I did not even mean to look up. I meant to look up. NVI0 IP address. It's an interface that gets created when you're creating NATing and stuff, right? And I didn't really know what that is, right? So it says here, the NVI is only used when domainless NAT. when using domainless NAT. It is normal to have the NVI shut down when not using it. So what is the NVI interface? When you enable NAT, legacy or not, the iOS enables a virtual interface called NVI 0. See, nah, I didn't really know this, man. And I have my CCNA. I didn't really know this. I didn't even notice it. I think because I use Packet Tracer a lot. I don't know. I don't even think it creates this virtual interface, now that I think about it. This interface is used only when IPNAT inside, or IPNAT enable is enabled. Well, I didn't do enable. I did IPNAT inside. This interface can be found with the command show IP interface brief, which we just did, right? So we did. No, we didn't. Let's do it now, right? Because we always run our show commands. Show IP interface brief. Come on, man. Brief, B-R-I-E-F, right? And there goes that interface right there. And notice it is up, and it gave him that same IP address, 10.222. So that's pretty interesting. I did not notice that, and like I said, I used to use Packet Tracer. I don't remember anything coming up like that. So this is why and this is another reason why I like using hardware too. So, but yeah, I think GNS3 would have. Y'all let me know if anybody's using GNS3 or even G doesn't create an NVI interface like that when you're doing natting. So what they said here, configure router 3 as the inside NAT, and so they want us to do that as the outside, right? This guy right here, do this as the outside. So we go back to global config mode, interface serial, yeah, 000, and he's gonna be IP NAT outside. Show IP interface brief. It's gonna look the same anyway. Way we check our natting is just by doing show IP NAT, I believe it is. Show IP NAT translations is all that. Show IP NAT. See what we got so far. No, let's do this. let me not do that. Oh, you can do NVI. I didn't know you could do this. NVI 0. Nope. You can't even look it up. What can you do there? NVI, and then after that, statistics. Ooh, okay. Or translation. Yeah, see, you can break down the enabled interfaces and when you see traffic going across it. But anyways, what we wanted to do, verify the, we'll run the show commands afterwards, even though we should do it now. We tested connectivity. We're on task 6. We're almost done here. Task 7 is the last task, right? He said here, same here, hopefully, static pool, access list, overload. That is what we will do tomorrow. Overloading or dynamic natting. Right? Tomorrow we're going to do that. Dynamic network address translation. Yes, we're going to do that. And I believe we're going to do port or overload and the day after that. Yes, port address translation, which is also known as, I believe, overload. Next, create a static NAT statement on router 3, mapping the inside address of 10.224, interface VLAN 150, to the outside address of 192.168.54.4. So I'll read that back to y'all, right? Hold on. So they said, create a static NAT statement. So we're going to basically have this IP address translates to that address. That's basically what we're going to do. That's what the static NAT statement is going to do. On router 3, mapping the inside address 10.224, which y'all don't see him. Oh yeah, y'all do see him here. So they want us to do this inside IP address, map it to the IP address of 254.4. You don't see a 254.4 here, right? Right? Y'all don't see it, right? Well, you see a 254.1 here. You see 254.2 here, right? Well, they said they want us to map it to 254.4, which is in this IP address space right here. It's in this IP address space. We're just going to be using this to do our NAT translations, right? So that's what that address is. It's not configured, like I said, it's not configured on router 3, but it's basically, that's the address we're going to use for our natting. And I think that's what what the NVI is going to get, if I'm not mistaken. No, I don't think that's what he's going to get. Let's just see what he's going to do. So I'll show you how to do that. You go to global config mode, and you say IP NAT, and they said source is what we're going to do. So this is the source right here. Source address 10.224, right? A question mark before I even show y'all. Context sensitive help says, are we doing a list? No, we're not doing an access list. Are we doing a route map? No, we're not doing that. That's CCNP stuff. Static. This is what they wanted to do. Static mapping. A local to a global address. Right? And remember what I said about local area network versus the wide area network, right? So this is wide area network. This is local area network. We also, oops, my bad, I put a 4 there. This is the local area network. The local is also just known as the inside local address, right? This is going to be outside, right here, right? This side is going to be the outside. But just remember that, in a way, he is an inside router, and this is guy going to be an outside router. So remember, there's going to be like, there's terms like inside global and outside global and all of that. Just remember, he is the inside guy, and he is the outside guy. He is going to have an outside local address, believe it or not, or outside global address. This is his outside global interface, and this is going to be the outside local interface. I know that sounds kind of like contradictory, outside local and all of that, right? I'll pull up, maybe after class, I'll pull up something that's going to kind of clarify it right here, rather than my 3rd grade drawings and stuff like that. But just remember those terms right there: inside global, outside global, and local inside and outside. So we said in IP NAT source, inside local is this. That's the inside local address. So 10, or static rather, we're going to do static. And then question mark again, we'll see the source local IP address is that guy right there, 10.224. So 10.2.2.4, right? Question mark again, it's going to say map. We're going to map it to what? Do you want to map it to a specific interface or the IP address? Well, they said map the inside address of 10.2.4, this guy right here, to the outside address of 192.168.254.4, right? Remember we said this is 254.2, that's 254.1. They want us to map this IP address to 254.4, right? I know it's not an interface on this router, but that's what we're going to do here, right? So 192.168.254.4, right? And then if you question mark, you'll see what else you can do here. All this other stuff, I don't even know any of that does. So this is basically what we're going to do to define the mapping. So remember, we did the inside interface with IP NAT inside. We did the outside interface with IP NAT outside, and then we created the actual NAT statement, which is this right here, IP NAT source static, right? We press enter. Oh, it's already mapped. I already did that, so I don't know why I did it again. And it tells you right there. I'm glad I did that because I've never seen this before. 10.2.2.4 has already been mapped. 10.2.2.4 is actually mapped to this IP address right there, right? So that's one way to even see. If you try to do it, it's going to let you know it's already mapped. You can also do show IP NAT translations, and it hasn't done the translation yet because we actually got to send traffic to even see that, right? But you can also do show IP NAT statistics. None, because we haven't sent any traffic yet either. So that was task 6, the final task. I know y'all waiting for me to wrap this up, right? Because we usually wrap this up in about an hour, right? We did task 6. Task 7 was to ping from switch 1 to router 1 and verify that the ping is successful, right? So switch 1, this guy right here, to router 1, this guy right here. So they basically want us to have us ping across to that guy right here, right? And remember, last time we tried to do that, it actually failed, right? Because switch 1 didn't know about this network right here, right? And since we did we do any we don't have to do any static routing in here, right? Did they want us to do a static address? No, I don't think they did. I guess they didn't want us to do no routing on here. Okay, so ping across. Let's pray to the network guys and we'll see if we can do that. Switch 1. No, my bad. I'm on the wrong device. We'll go to switch 1 and ping 192.168. Hopefully we ain't got no troubleshooting to do. Ping 254.1. He's hanging there. Pray to the network guys. Doesn't look like we can ping across. So let's verify our work here. We have switch 1 ping router 1. Let's verify that this interface is up. And did we do some routing here? We said from switch 1 to router 1, which is what we did here. We did the mapping 254.4. Wait, he said 54.4. Yep, I did that. Verify the pins. Next telnet from router 1 to that from router 1. From switch 1 to router 1. Yes. So, and then after that, they're going to have us Telnet from here to there. But before we do that, we need to figure out what's going on here, right? So, let's see. Let's go to router 1 and verify the interface is up. Show IP interface brief. And 192.168.254.1 is up, right? Let's verify his subnet mask, /29, right? Show IP interface serial 000. Just started watching your free CCNA subbing material. Thanks, my guy. Appreciate that, Joseph, man. Hit me with that like button and make sure you subscribe, man. /29, that is correct. So 192.168.254.1. All right, so that's correct. Looks like we got some bonus troubleshooting today, man. Hopefully it ain't no fat finger mistake here. So we're going to router 3 and check these IP addresses. We're going to check that guy and that guy, right? Show IP interface brief. We said 10.222 is the FA00 interface. I might have to check my cabling too. That's the other thing too. That's the other thing I might have to check. But I'm pretty sure it's pretty good. Let's verify his subnet mask. Show interface FA00. His subnet mask is /27. That is correct. 10.222/27. So that's correct. And he's up. Let's go to that interface right there. 0.000. Show IP interface serial 0.000. Remember, your interfaces might be different. 192.168.254.2/29. That is correct. What else? The default gateway should be 10.222. So we did have switch 1 ping the default gateway, didn't we? Let's verify that. Switch 1. Can he ping his default gateway? 192. It is and it's /27, right? We said it's /27. Yes, it is. 10.224. The switch 1. Is he 10.224? Let's verify that. Is there a static route? No, there isn't. That is a good point, and that's what I was wondering. I was like, how come I don't remember? Did we skip anything about any routing or anything? Because you would think they would have at least have us put in a route. Another thing I like about this book is if we don't know, there is a solution guide towards the end. If you guys are following on for the first time, this is the book we use, 101 Labs, Cisco CCNA version 4. You need to copy this from 101labs.net. There's also a link in the description box below. It is an affiliate link, so I do get commission off of it. So this is the book that we use. We're halfway through the book. We're on lab number 63, even though it says 101 labs. There's about 120 labs in here. So once we get done with this, we're going to move on to the CCNP version of this book right here. So we did the source. That was correct. I did let's see here. Interface VLAN should be up. Router 3 has his IP addresses there. Yeah, it don't look like I missed anything. We did the clocking. And that's a good question. They didn't say anything about static. There is no static route on here that they asked us to do. They didn't design it that way. We probably could just add it, but y'all know I don't like to veer off the lab and stuff and create, just kind of jerry-rig the lag just to get it working to show y'all that it's working, right? So let's go back to switch 1 and let's verify what I did on there. Show IP interface brief barf. Exclude unassigned. He is 10.224. Interface VLAN 50. He is up. 10.224/27. What else they wanted us to do here? Can he ping that default gateway? We did this already, right? We pinged that guy right there. Did we ping him? Let's verify we can ping him, man. Let's verify that. 10.2.2.2. Yes, he can ping him. Can he ping that guy right there? Let's do that, right? Let's just do some basic connectivity here. 192.168.254.2. And he can ping that. So he can get there. So he can ping that. This right here. And then he can ping this right here, right? Now, can he ping the remote gateway right there? 254.1. Let's do that. 254.1. That's what we actually tried to do in the first place. He can't get there. He cannot get there. So it's probably router 3 has probably got the issue. This guy, we probably got an issue right here. Let's go to router 3. Router 3. So we got some bonus troubleshooting here, right? Show IP routes. Does he? I'm sure he's got a route to the damn 192.168 network. 254. Yes, he does. 254.2 is local. He just can't get to 254.1 for some odd reason. That's weird. Why do I have a /32? Oh, it's /32 because that's the exact IP address for it. That's why. But let's look at what we got so far, right? Show IP, interface, brief. We got some bonus troubleshooting here. And no, I'm not meaning to do this on purpose, y'all. I'm actually, there's actually something wrong here. We need to figure this out. So this kind of throws me off right here. Why does that say 10222 along with that guy right there? And remember, this is the like the virtual interface that gets created once you create a NAT statement, right? And it is up. He's 254.2. Is directly connected to that network. Can router 3 ping 254.1. Let's do that. Ping 192.168.254.1. He can. Interesting. So he can ping that right there. However, switch 1 can't ping that guy right there. Can router 1 ping switch 1? Let's do that. Router 1 ping 10.2.2.4. He probably can. He probably can't. Router 1 cannot ping. Nope. So basically, router 1 cannot ping this guy right there. Something wrong. Let's figure this out, y'all. Switch 1 is interface VLAN 50 up. It is. It is up 10224. What he said? He said I thought it was down serial 000 on router 1. Was it? I don't know. Good eye. If it was, let's verify that. Show IP interface brief. It is up. Okay, good. It is up. I'm glad you pointed that out too. But that doesn't seem to be the problem. 192.168.254.1. That is correct. Remember last time we had this problem? It was a typo, right? And this is the reason why we call ourselves the Fat Finger Squad. So y'all help me find any kind of errors in here if there was any kind of typos, right? 192.168.254.1. It's up. What is going on here, fam? And I went over my limit. That is, y'all know I try to keep this underneath the hour to let you guys get y'all study in. And let's see. Can router 1 ping router 3's 254 dot ping router? So I'm gonna have router 1 ping that guy right there, which I'm pretty sure he will. He should be able to because he's directly connected to it, right? So 192.168.254.2. He can ping that. Can he ping 10.222? Ping 10, which was that right there, 10.222. So basically, I'm gonna have router 1 ping that interface right there, right? Can he do that? No, he can't. So because he does not know, maybe let's take his routing table. That's probably the issue. He don't know anything about the 10 network. And that's what they said in the book, right? Let me see. Let me verify that because they say he don't know anything about that network. However, since router 1 does not know about the 10.220 subnet, switch 1 will not be able to ping this. Verify that. Yes, that's true. But you would think there was some kind of, maybe they're missing a static route. Maybe we just need to create a static route to the 10.000 network. 10.222 network, right? Show IP routes. And that has got to be the reason why. Router 1, as they said, does not know about that network right there. So let's go ahead and create static routes both ways. Let's just do that. And let me verify they even got that in a solution guide, because you would think they would have asked us to do that. You know what? That's the issue. Maybe they just assume you're going to know, like, hey, you know you need a route to go over there. Like, how the hell you going to go to a city and you ain't got a route to go there? That's probably why they left it out. So I'll be reading these labs, you know, step by step. They probably left this out like, duh, you should know you need a static route to get there. So let's go ahead and create a static route, right? So we're going to go to global config mode and say IP route is how we create a static route. So who said that earlier? Show IP route on static route. Lee, that's correct. We figured out the problem. He ain't got a route to that network. and we got to create one. And just like what you said, is there a static route? There isn't, and the book didn't even ask us to do that. So that's basically what I think we got to do. And I think now that I think about it, I did a run before, and I was like, why they left that out? Maybe they did that just to, you know, not throw you off, but just to kind of challenge you. I don't know. Like, you should know you need a route. So IP routes, to get to the 10.2.2.0 network, subnet mask of /27, which is .224, right? Is that what we want to do? Or we could just put the exact IP address. We want wildcard mask. To get to that network, he said, what are the pros and cons to establishing static routes on both sides? Well, there isn't necessarily a pros to con. Yeah, actually there is. The pro is that it'll work. The con is that it won't work if you don't do it. So you need what's called bidirectional connectivity. So if you got a route to go one way, a static route pointing that way, if you want that ping to come back to you, you got to have a route coming back the other way. So that's your pro to con. One it'll work and one it won't. So, bruh, I banged my head on the wall many nights getting basic networks going. Hey, it's all good, Lee. The more you do this, the more you'll start to, you know like little simple stuff like this. So I'm sitting here like about to go over my time limit and realizing, oh yeah, duh, you need a fucking static route. Excuse my language, but not that I'm forgetting how to do it, but I'm wondering if I wanted to put a wildcard mask or how I want to do this. What I want to do is I'm gonna just do a default route. Let's just do that, just to simplify it. If for any other network, send it out the interface. So we're gonna just do a default route, right? Quad 0. Send it out the interface of serial 000, right? So if this guy says, I don't have a way to send this packet, the packet comes in, he don't know where to send it to, just send it out this interface. And that's what we're going to do with that serial interface, that static route. So quad 0, and we got to do the same thing on this side right here. So we're going to say the same thing for router 3. If you get a packet that comes in from that interface and you don't know what the hell to do with it, go ahead and send it out this interface, right? So that's what we're going to do there. Let's go ahead and do that. So we're going to go to router. We did it on router 1. We need to go to router 3 and do the same thing, right? So this is not a very specific route. It's a very generic IP default route, right? So, and we can verify that with show IP route, right? So IP route quad 0, 0.0 and 0.0.0.0. And they say, you don't know what the hell to do with it, send it out serial 000 interface, right? We can verify that with show IP routes, and let's see what we got. Right there. This says our gateway of last resort is to that network is quad 0. So you don't know what the hell to do with it, right? This is the S lets us know that is a static route. The star lets us know it is a candidate default, so we don't know what the hell to do with it. This is a possible default route. You might just say, you can send it out this way. Any kind of traffic, you don't know what the hell to do with it. And then it's directly connected to us. Send it out a 000 interface, right? I know it says 200, but mine is 000. Same thing with this guy right there, right? So we set a static route going this way, and then we set a static route going that way. That's what static routes you need to do. Have it both ways. Now dynamic route, OSPF, EIGRP, it already does that for you. You ain't got to do all of that. You just got to put network statements on both sides. But that's kind of a little something off topic. Go back a couple videos if you want to know more about that stuff. We'll cover those other routing protocols again. So now let's try to have, what was the last task? Have switch 1 ping router 1? Yeah. So we're going to have switch 1 ping router 1. That's what they wanted us to do first, right? And he was 192.168.254.1, right? So let's go to switch 1. That guy right there. He said, gotcha, makes sense. Yeah, that's your pros and cons. The pro is it'll work, and the con it won't. So ping, hopefully that works. 192.168.254. If not, we got to probably make a more specific static route, and we got to reply. So we're good. Pray to the network gods, and you got to reply. And most likely, if it works one way, then 9 times out of 10, it's going to work the other way. That's what bidirectional connectivity does for you. So we'll go to router 1. They said we ain't got to do it the other way because I proved to you it already worked, but we'll do it anyway, right? So we'll have him ping 110. So we're gonna have him. Let me show y'all real quick. We're gonna have router 1 ping that guy right there, which is 10.222 or 10.224, right? So ping 10.2.2.4. And pray to the network guys, we got a reply. Good. 100%. So next, Telnet from router 1. So we're going to Telnet from router 1 to switch 1. Remember, we allowed Telnet to come across this right here. Right? Telnet. I'm not going to write a whole damn word, but that's Telnet. They wanted us to allow Telnet on switch 1 earlier in the lab. And verify that you are connected to switch 1 via the NAT configured router 3 statement, right? So we are going to Telnet to, we said 10.2.2.4, and notice we're getting prompted for the password there, right? If we'd have left out that no login, it would have just let us in, even though we got a password set up for it. I think, right? If it asks for the no, it won't even prompt you for it. You'll just get granted access. So the password was all caps Cisco, right? Because we choose secure passwords like that, and we're in switch 1 right there, right? So now we are telnetted from router 1, and we're in switch 1's console, right? Because see, we're on router 1 still, but we're actually in switch 1, right? And you can see what else they wanted us to do. They said to verify we're connected to switch 1 via the NAT configured on router 3. So we're gonna go to router. Actually, we'll just do this. We'll go to switch 1. No, we got to go to router 3 and then run check the NAT statements, right? Because natting is done on this guy right here, right? That's where the NAT is done, right? We got the inside interface right there, and then the outside interface right there. We can't check NAT on this guy. We can't check NAT on this guy because he is doing the translating, right? Network address translation. Show IP NAT. Remember we tried to run this earlier. Translations. That is not how you do it. Let's check, not translations, but let's do this. Show IP NAT. Did we do we did a translation. What the hell? Show IP NAT statistics. There ain't nothing there either. That ain't right. Interesting. Because we have our outside interface defined there and our inside interface defined there. Maybe we do got to run it on the other guys. Do we? No, we don't. No, we don't. Show IP NAT. You ain't gonna see all of that over there. No, you got to do it on the switch. I mean, on the router. This guy, router 3. We should see some translations there. That's rather interesting. Maybe because I use the interface right there. Let's see. Let's verify. We're pretty much done with the lab here, y'all. But there's something wrong there. There's something that that's not showing that we're translating there. Says the note. This is what I love about this book too. The solution says here, you can look at translation statistics using show IP NAT statistics, which we just did right there. If you are having issues with NAT, this command show you the hits versus misses, which indicates successful versus unsuccessful translations. Use these counters to troubleshoot network address translation. If it isn't working, check that you added the NAT statements to the interfaces and the default gateway to the switch. Well, we did the default gateway to the switch, right? For sure, right? With the with this right here, show IP. We'll do the show IP routes, and then default gateway is 10.2.2. What else we got to do here? So that's our default gateway. They said to verify. Let's see, if you're having issues with NAT, this command can show you the hits versus the misses, which indicates successful versus unsuccessful. Use those counters to troubleshoot NAT. If it isn't working, check that you added the NAT statements to the interfaces, which we did. Let's see here. It says one static NAT. It should have been a network. Let's see here. Show IP NAT translations. We did that. We're not getting any kind of translation here. Let's see here. Let's see here. Show IP NAT statistics. Show running config. Let's see NAT. Okay, good suggestion there. Show run. Let's just do a show run real quick. Show run. And let me see here. NAT. Where is it? NAT. The NAT statements are not in here, are they? No, that's on the switch. That's because I'm on the switch. What am I doing here? Show run include NAT. Let's do this. Let's do a whole show run real quick. Show IP NAT. IP route, NAT static source 10.224 to the 192.168.254.4. Y'all give me a minute here. Give me just a minute. Hello? Y'all give me just a minute, man. Y'all give me just a minute. Ugh. One moment. All right. My bad, y'all. All right. My bad, y'all. Okay, so let's see here. Where were we? We just wanted to check the address translation, right? So IP address was it was pingable, so we was able to ping from router 1 to switch 1. That worked just fine. From router 1 to switch 1, that worked. We just can't get switch 1 to router. I mean, the NAT translation, which was show IP NAT statistics. We did that. We did not see any kind of statistics here. Let's see. Figure out true. That's interesting. That is right. Okay, so you said yeah, show running config. Let's see. You're good, bro. Hopefully not a network issue at work. No, it's not, man. It was just a little side thing. So we ran, okay, so we did that. That was the translation there. That was correct, right? So the inside is that. Let's verify this. Because they didn't want us to do. I'm gonna run that back. Run that back. That one task was. Let me see. Test connectivity by pinging. Where was I? Inside NAT stored static. We should all be successful. Yeah, mapping the inside address of 10.224. That's what it was. So task number 6 is what it was. So create the static NAT statement from on router 3, mapping the inside address of 10.224 to the outside address of 192.168.254.4, which is that statement right there. Now, what we need to do is verify that this was the outside and this was the inside. That's probably what I need to verify right there. Let's do that. Which I'm pretty sure it would have, yeah, it still would have pinged across. It still would have pinged across because of the static route there. So, yes. Outside is 254. Yeah, this is the outside interface. And FA00 is the inside interface. So that's correct as well. And this is that NVI00, I believe, what that was. Remember that NVI0 that we saw earlier when we did show IP interface brief? Where's he at? Where they at though? Where they at though? That interface right there. That's what that command is. I used to see that a lot of times, like at work, and run into the commands. I'm like, what the hell is virtual reassembly in and all of that? That's basically what that is. That's for any kind of NAT statements and stuff like that. So those are correct. That is the inside statement, right? The 10.222, and that's the outside 0.000. Let's verify what that's what they asked for, right? They said, yeah, that's it, man. So I don't know. I couldn't tell you why we're not getting on it. We should get some kind of like counter statistics. Anytime you like translate across or ping across, so like we have router 1 ping this guy over there, right? As soon as he do that, there's going to be traffic going across the interface and that interface right there, right? And we should get some hits when we do show IP NAT translation. So IP NAT translation like that, right? That's what we should see. Theoretically. So if we do that again from router 1, let's do that. We're gonna have ping 10.2.2.4, and it could be 2 because we put the exiting interface as 0.000. That's what it could be. We should verify the next hop. Let's try that. I'm gonna try that real quick. So that came across, right? I'll do it again just in case. Show IP NAT translations again. Nothing. So let's do this. I'm going to change my default. I mean, not my default with gateway, but the... remember, we already done the lab here and stuff like that. We just want to make it so that way we're getting some kind of counters going up on the show IP NAT statistics there. So let's do this. I'm going to change this static route right here. This right here. Instead of using 0.000, the exiting interface, to get out, we're going to use the next hop as our for the static route, right? So let's get rid of that static route, which was this right there. So capital A, no, this, right? And we're gonna say IP route that, take the next hop of 192.168.254.2. Let's do that instead. Nope. No, that's router 3. That's wrong. I did not mean to do that. I meant to say, so he is supposed to be, he is going the other way. So he's going the other way. So he's 254.1, my bad. 254.1, right? And then the other guy is 254.2. So this guy is going to be on router 1's router, right? Or router 1's, so no, where's that? No. What was his IP? What was his route? What was the route he used? He used this. We need to get rid of that. No, this. And we're going to say IP route quad 0. Let's see if that makes a difference. Dot 0. Next hop of 192.168.254.2. Show IP routes. And we'll see that is our default gateway right there to the network. Oh, but now he doesn't have a way to get to that network right there. That's the problem. No, it's not. It's not. Let's see if we can ping across. 10.2.2.4. We got a reply. Okay, good. So now let's go over here. So router 1 can ping that right there, right? I drew it twice just in case y'all didn't see it the first time. And let's verify show IP. What was it? from NAT translations. NAT. Y'all know I'm getting some brain farts and stuff over here. Nope, that still didn't come across. And if we do show IP, what was the other one? Because I've seen it before. Statistics. We're not getting any hits. So there's something wrong here. I'll probably have to research this tonight and let y'all know. Because, yeah, see, we're not getting any kind of statistics. We're getting the pings that go across, but that's because of that static route. We're not necessarily translating. So you would think, yeah, they would have at least said something here. Let me see. Let me just verify. Also keep in mind, because you configure static NAT, you will not see any dynamic mappings, and that is why. they also put that in the book there. So, but you would still see some hits though. You would at least see some hits, and right now the hits are 0. So they said at the end of the lab. Also keep in mind that because you configured static NAT, you will not see any dynamic NAT mappings or translation statistics until you configure dynamic NAT. So that's the reason why we're not going to get any translations. I thought we would have, so I guess I was just overthinking it there. Yep, I was overthinking it, but I thought we would at least get some hits though. I thought we would at least see some hits, but apparently not. Active translations. Okay, so that's probably why. Oh, good to know. From now, y'all want to follow along next time? We're going to be doing dynamic network address translation tomorrow. That's another reason why I kind of like, Natting kind of trips me up. I know when I was taking the CCNA exam, this was one of those topics that kind of like confused me and stuff like that. Like as far as the inside global and outside global and stuff like that. We'll go over it after this stream here, if y'all want to stick around. Yeah, this was one of those topics that kind of tripped me up. So Friday when we were supposed to do the stream, I was kind of, not Friday, Thursday. I was supposed to do this lab on Thursday, but y'all know I had some stuff that I was really busy at work and stuff for, and couldn't get to it. And plus I was just like kind of nervous about network address translation. So luckily we was able to wrap it up and get it done today. Tomorrow we're going to do dynamic natting. And that's pretty much it. If y'all want to follow along next time, get you a copy of this book, 101 Labs, Cisco CCNA version 4. You can get a copy of this from 101labs.net. It's authored by Paul Browning and Farai Tafad. There's also a link in the description box below, and you get it's a link that'll take you to Amazon to get the book. So I'm just forewarning y'all that, because YouTube done took me down because they thought I was trying to get people off of the YouTube website to an external website. No, I was just trying to get people to get this book over here. I didn't write it. I'm getting a small commission off of it, but you go to Amazon and get the book. So you can also get it from their website, 101labs.net. So anyways, if y'all want to follow along, make sure y'all join the Discord server. If you want to know, like if I cancel a stream or anything like that, or if I'm going to do an extra stream, here is a link. Debug IP NAT. Yes, that's a good thing too. We could have done too. Let's do that. Debug IP NAT. So I thought you would at least see some kind of and I did another lab on my other I did another like hardware lab, and I did see at least the translations. So I thought I would have at least seen that. Maybe because no, because I was gonna say if you had an external device with that IP address plugged up to that, and then to try to ping across, but you should. I thought it would still at least get some hits. But yeah, that's a good thing too. Let's have him ping 10224 that way. Debug IP NAT. You see, ain't nothing happening there. So that's a good point though. So we turned on debugging on router 3 right there for natting, right? And then we pinged across and nothing happened there. So let's see if switch 1, what happens if he pings. I'm gonna have switch 1 ping that guy right there and see if if we get at least something on the debugging. 192.168.254.1. He did ping across, but nothing there. See? I don't know. That's weird. I thought you should at least get some hits on the inside interface. It says inside interface. Yeah, so that's the inside interface and that's the outside interface right there. So I don't know. Y'all let me know. But y'all go ahead and join that Discord server. For now, comment, like, subscribe to the network. Cue my bro here, but my phone is slow. tune into the network. But y'all can stick around too. So what was I going to try to figure out here? Yes, I wanted to go over this with you guys. Y'all know the stream is done. This is just kind of like an after class thing here. So outside global, and this is going to be pertinent to tomorrow's lab as well, right? Let's see outside. Let's do this. Let's do NAT. And I actually had to look up an old video that I did on Natting too to kind of, you know, refresh this topic here. Static NAT. Where we at here? Images. I want y'all to take a look at this right here. Like outside global versus inside and all this other. There was one that I saw that made it kind of clear for me. Which one was it? This one right here. Even though it's one color, I like this one. Types of network address translation. Right? Okay, so what's going on here? Get off my face, man. What the heck, man? Shit. All right, so, oh my goodness, man. All right, so remember, this is similar to what we had. We had two routers, right? There's this router right here, and there's this router right here. This now we're going from left to right. This is gonna be the private network, right? That side right there, and then this is gonna be the public network on this side right here of the internet, right? Well, actually, all this right here is the wide area network right here. Even that router right there, right? So if we are here, this is what's considered the inside local address, right? If we do show IP, remember this right here? What they was trying to show us? Well, nothing came up because we're not doing dynamic natting. But this is going to be really pertinent for tomorrow's lab. So show IP NAT translations like this right here. Right? You said Discord link not working. Says expired. Seriously? Interesting. Let's do this again real quick. Oh, I see why. I see why. My bad. Here, this right here. There is the link. Y'all let me know if you can get to the Discord with that. I didn't know they expired. That's interesting. Rather interesting. Good to know. I appreciate you pointing that out. But we do show IP NAT translations. You're gonna see an inside global address, an inside local address, outside local address, an outside global address. Don't that shit sound contradictory right there, man? Outside local, outside global. Well, think about this. Anything that got the word global has to do with the globe. Outside, wide area network. Global, 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 right? And then local is internal, right? So this is the inside router, and this is the outside router. The inside router is our router on the edge of our network, right? So we are on the local area network right here, right? So this is the inside local address right there, the actual address that you're going to translate. And then this is inside global, right? The outside of the, I know, remember we said this was inside interface, inside NAT interface, and that's the outside NAT interface, right? But this is also the inside global address. I know that sounds kind of confusing. That's what used to confuse me with NAT. You got outside global, inside blah 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 blah, right? But remember, this is the inside. This is how we break it down. This is the inside router. That's the outside router, right? And then we're gonna have local, inside global. It's on the on the network, right? So they notice they both start with inside. This is the inside router, and then local, right? The local guy, and then global. He's on the outside of the outside of the internal router. See how, like I said, it sounds kind of contradictory there, but just remember, this is the inside router, it's the outside router, right? So when we're talking about, like, let's say we have some kind of device or something that's on that side of the spectrum or whatever of the network, and we need to get to it, we're going to define this as the outside router, right? So this is the outside global address, and this is going to be the outside local address. Does that make sense? Right? This is the outside global, outside local. Inside global, that says inside local, but anything that's going to be in here is going to be inside local, because we could have separate hosts that are going to be translating to this outside global address or inside global address. See how I get tripped up? Damn it. But remember, inside router, outside router. Does that make sense? I know I said it 500 times, but I'm trying to do this so that way it sticks in my head. Because I remember I covered this before, and I'm like, right when we started doing that today, and I'm like, shit, how I forgot it. I forgot what was inside, outside, and all that other stuff, right? Until I watched the old video that I had in my archives, and then I remembered, oh yeah, that's right. There's an inside router and then an outside router, and each one of them has an inside and outside interface, but we refer to them differently. So, but there's what else here? What else did I wanted to cover? I thought, you see, this is the other thing too, man. I thought this would have at least given us some hits, man, because we sent some traffic across. That's rather weird, man. So yeah, remember, outside global, outside local. So this is the other guy. This is the other router. Once he starts learning about it, it's the other router, and then this is the inside. This is us, our internal side of the router. So if we look at our topology, right, and we define it, right, let's go ahead and define that, right? We said that we made this the outside interface. This was the inside interface right there. Right, he's the inside interface. We made this one the outside interface right here, out, right? And then this is going to be the local area network, right? Us right here. This is the inside. Let's do this. Let's not do it that way, right? We're going to say this is the local area network right here. Local area network that way, right? That's the local area network. So this is the inside and that's the outside interface, right? But then when we say inside local address, this is actually the inside local address. And this is the outside, what is that? That would be considered the inside global address. Does that make sense? Remember, because this guy's going to be the inside router. So this is going to be the inside global address. From his perspective, switch one, we're going to say that this is the global, right? This is the global router because he's out in the globe in a wide area network, outside global wide area network, right? Over here, right? Just think of a globe, right? This is the global router. So this is going to be the global, right here. This is going to be the outside global right there. This is the outside global address. Outside global address. Right. So this right here is the outside global address. Well, guess what the outside local address would be? Well, guess what? We don't have one. But if we had, like, let's say a server or something right here, that would be the outside outside local address, right? See how it sounds tricky, right? It sounds tricky. Just this is how I'm gonna remember it right here. This is gonna be the global router, and then this is gonna be the local router, right? Is that what I'm saying? Yes. No, because we also have the inside router has an inside global address. So no, that's not. We don't want to call it global. We don't want to call him global. We want to call him something else. He's I guess he could be the outside router. I don't know. That's what makes it hard to kind of to differentiate there. But yeah, that's pretty much it, man. So yeah, tomorrow, dynamic natting is basically, so this is what we did here, right? We mapped one IP address internally to one outside, right? And that's why we call it one-to-one mapping, right? Next time we could have like 30 internal addresses, right? 30 internal, and they're gonna have like, this is 10.2.4, and he could be like .5, and he could be like .6, right? But they all gonna be sharing this one outside address when they talk out, right? So anybody that want to reach us going inside, they're gonna be talking to us using this address right here. Sorry for my scribbling and stuff like that, but and this is like a one-to-many mapping is what they kind of call it, but it's called dynamic because shit, not that it changes, but how do I say this? I guess we'll go further into it tomorrow. I don't want to give y'all too much of a spoiler alert. That and I don't remember. Not that I don't remember, but it is one-to-many mapping. So let's see what it says here. If I remember correctly. 254.4. That is what I did with that, man. I'm confused. I'm still kind of. I won't be able to sleep tonight, being that I can't figure out why those translations that it didn't get me hit on those translations there. But we was able to ping across and it worked. But I think that's due to the static address though. So who knows? Configuring dynamic. We'll be creating a pool of addresses. Oh yeah, this is gonna be a little tougher too, because they're gonna have us create an access list, and they didn't even introduce access lists yet. So yeah, I really need to go over tomorrow's lab. So let me go ahead and shut this stream short and kind of look over this stuff tomorrow. So I am prepared, and you guys are prepared as well. Y'all get you a copy of this book, man. Comment, like, subscribe to the network.